Hey, geometry! Part 3 of our 3-part series of Introduction to Trigonometry. So previously we did an intro video where I taught you SOHCAHTOA. Hopefully by now SOHCAHTOA is ingrained in your brain. Some old horse caught another horse taking oats away. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent, opposite over adjacent. If you're still fuzzy with that, go back and watch that video again. Watch other videos on YouTube. Okay, there's plenty of them on the internet. So, the second video, we found sides. Okay, we found sides. Now, finding sides, we use SOHCAHTOA. Now we're going to find angles. Okay, so we're going to find these angles. So we're after finding theta and alpha. So in this case, we know these two things. So question 1. I guess we'll continue with our think box here, since that's been a theme, our think box. What do you know about x? X is going to be smaller than 10. Okay? Now what else do we know? Well, until we really know what x is, we don't know what these angles are going to be. So we can't really tell which angle is going to be bigger. So we're going to have to just stick with that. X is less than 10. But you know what? We can find x right off without even using sine, cosine, or tangent, without using SOHCAHTOA. Because we have the power of Pythagoras. We have the power of Pythagoras. So if I want to find x first, guess what? Okay, 16, that's 100. 100 minus 16 is 84. Square root that. Square root of 84 should just be a little bit more than 9. So let me find out what that is. Control square root 84, 9.165. So x is about 9.165. Rounding off to 3 places, x is 9.165. Guess what? Nothing new yet. Oh, we used Pythagorean Theorem. Yeah, we did that in February, back when things were still normal. Okay? So 9.165. X is 9.165. Now, how are we going to find these angles? This is new. 9.165 is new. So how are we going to find the angles? We got to find these angles. Okay? So, theta and alpha. We're going to set up SOHCAHTOA. Folks, when I set up SOHCAHTOA for here, my first question is, do I know the hypotenuse? Do I know the hypotenuse? In this case, the answer is yes. That means I'm going to use either sine or cosine. If the answer is no, you have to use tangent. That's how you decide which one to use. So in this case, I know the hypotenuse is 10. Now let me tell you something here. We don't want to use 9.165. Why? Because 9.165 is a rounded number. 4 is much, much better to use. If we use 4, we're typing in 4 and a 10. And 4 is not rounded, 10 is not rounded. They're nice numbers. So I want to use sine or cosine to find one of these angles. Does it matter which one I find first? No. But you know what? These 3 are right here. So I'm going to use, I have the hypotenuse is 10. Hypotenuse is 10. I have 4. If I use angle theta, how is the 4 related to theta? It's the adjacent leg. That's cosine. Cosine of theta is 4 over 10. In this, don't use a 9.165. If you do, I'm not going to mark it wrong. I'm just saying that you're going to get a slightly different answer because of rounding. Your compounding error. That number was rounded. If you use that number to find the angle, you're compounding the error. The rounding compounds itself. So cosine of theta is 4 over 10. How do I do this? How do I get a degree out of that? Well, that's why we have these things. Okay? Back when I was in school, when I took trig in 1986, we didn't have these fancy things. Some of us did. We had to use tables. We had to look up tables in the back of our book and interpolate and extrapolate. It took us a week to learn how to use the tables. I'm going to teach you in 2 minutes how to use your calculator. Okay? So this is cosine. Here's what you're going to hit. You either have a control key or an inverse key. And here's what we want. We want inverse cosine. So we want this. We want this. Cosine to the -1. It should be its own key. Don't hit cosine and then find the -1 key. It's not going to work. You should have a button on your calculator. Shift cosine, control cosine, something. Maybe it's its own button. If you have an inspire, it's on the drop-down trig menu that's right next to the number 7. Again, if you don't know, reach out to me and I will help you with your calculator. Inverse cosine, parenthesis, 4 divided by 10. So I already put in my inverse cosine. I'm going to put 4 divided by 10. I'm going to hit enter, and here's what it gives me. 66.4218. In this class, I'm trying to keep things simple. I only care about the whole degree. So round this off. What are you going to round that off to? 66 degrees. Next year, if you take trig, you'll get into parts of you'll get into the parts and stuff, and blah, 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 and then all minutes and seconds and all the other stuff. Don't worry about it. We're just going to round that to 66. So theta is 66. How do we get alpha? Well, if you're thinking about alpha, if you're thinking about doing this, if you're thinking about sine of alpha is 4 over 10, good for you. But we don't have to do it that way. There's an easier way. If I know one angle, how do I get the other one? 90 minus 66. So we're going to go 90 minus 66. And what is that? 24? 24 degrees. If you do this, for extra practice, inverse sine, you'll get 24. It'll round off to 24. But all you have to do is find. So really, these angle problems, you only got to do it once. Okay? Let's go through really fast. We'll do one more of one where we have to use tangent. Okay? So let's do a tangent problem. Let's do a tangent problem. Theta, alpha. Let's say this is x, this is y, and out here, let's say this is, let's make this a 10. So there's what we're after. No, I got to give you the y too. Sorry, I got to give you this. So x, that's 10. Let's call this 5. Okay? So we got x, alpha, theta. All right? What's our think box? What's x have to be bigger than? X has to be bigger than what? 10. Got to be bigger than 10. Why? It's the hypotenuse. How are we going to find that hypotenuse? Well, Pythagorean Theorem. Okay? Pythagorean Theorem. So 10 squared plus 5 squared, 125. Control square root 11.18. So guess what? X is 11.18. I'm not taking it through the steps for that because, boom, you should know how to do that. Okay? Pythagorean Theorem. So, what do I want to do here? That's 11.18. I do not want to use 11.18 to find one of these angles. Why? Because 11.818 was rounded. So when over here, let's go to this other box that I left up there from the last problem. If you know the hypotenuse, and do you know the hypotenuse? Question mark. Yes. Use sine or cosine. We didn't know the hypotenuse, so we got to use tangent. We found the hypotenuse, but we don't want to use it. Let's use tangent. So we're going to go tan. Let's find theta first. Does it matter? No. If you want to find alpha first, go ahead. You can pick whichever one you want. Either way, tangent of theta, SOHCAHTOA. Again, SOHCAHTOA. Tangent is opposite over adjacent. What's opposite theta? 10. What's adjacent theta? 5. 10 over 5. Can you figure out 10 over 5 in your head? I hope so. It's 2. Theta. Inverse tangent of 2. Inverse tangent. Where's inverse tangent? Well, wherever you found inverse sine and inverse cosine from the last problem, that's where you're going to find it here for tangent. Inverse tangent of 2 gives me a degree of 63.435. 63.435 degrees. What do we do with the 0.435? We round it off to the nearest whole angle. That's 63 degrees for theta. How do I find alpha? I subtract it. 90 minus 63 is 27. When you first look at the find the angle problems, they look a little screwy. Writing out inverse tangent seems a little weird, but once you get the hang of them, these problems are actually easier than finding the side problems. Okay? This is the last lesson in our trig chapter. Okay, so there's 3 videos here. We're not going to do anything else with trigonometry, except we are going to practice these so much so that you know what you're doing. It's going to comprise most of the rest of the year, the next 2 weeks anyway. We're going to do a lot of these. Well, you'll probably already practice the sides because this is the last video. So we're going to practice a lot of these, and we'll get one big quiz on the trig stuff. And then after that, I'm not sure what we'll do. We might do some stuff with circles, but I'll figure it out, okay? I hope you're safe. I hope you're doing well. I hope you're not bored. And good luck with this. If you need help, office hours, Monday, Wednesday, Friday, 9 to 10. There's the problem. And hopefully we'll all see each other very soon.